Okay, so today we're going to look at the power rule. For the first example, we're kind of derive it and get this property down here, and then we'll do 4 examples. So on the top here it says, how many factors of 2 are there in the expression 2 to the third squared? Use your answer to write the product of a single power of 2. So another way to write this, instead of saying 2 to the third squared, is we could write this as 2 to the third times 2 to the third. And if I write that all the way out, I have 2 to the third, which I could write 2 times 2 times 2, or 2 times 2 times 2. Or you could just use the property that we already talked about, the product rule, which gives us 2 to the sixth, when you add these exponents up here. The other thing is I can count these 2's, and I see that I have 6 of them, and I can write this as 2 to the sixth. The relationship we really want you to see is what happens between these exponents. What operation occurs between 3 and 2 to give me 6, and that would be multiplication. So when you see something set up like this, where a base and an exponent is separated by parentheses, raised with another power, right? That's why we're going to call this the power of a power property. We are going to multiply the exponents. And that's it. We're going to focus on this idea that if I have a power raised to another power, then I'm going to multiply by the exponents. So here are the examples we're going to look at. Let's start with these first two. If you notice, I have 3 to the third, and then I have to the fourth. Of course, I can write this out as 3 to the third times 3 to the third times 3 to the third times 3 to the third, or I can look at just multiplying these exponents. I could do 3 and then to the 3 times 4, where I could write this as 3 to the 12th. And as we talked about with numerics so far, just stop at 3 to the 12th. We're not going to go forward and simplify this any further. If you look at this one, I have 2 to the negative third times negative 2. If I multiply these, a negative times a negative gives us a positive, and then 3 times 2 is going to give me 6. So this is going to give me 2 to the 6. And I'm going to stop there. It's as straightforward as that. The last thing I want to show you, and it kind of spills into what you're going to be looking at, with products and quotients the next lesson, but we might as well get it down now with coefficients. If I have something like this, 4a to the third with a squared and 6b with a squared, all you need to do is pay attention that that squared is going to go into both terms and kind of handle them each separately. Meaning I have to do 4 squared, and then as we just talked about, this is really a to the third times 2. This we could simplify. 4 squared is going to give me 16. And then this can give me 3 times 2, which is 6. And that would be my answer. So again, you're going to go over this a little bit more next lesson. I just want to show it with coefficients now with a number, because you're going to do it more so with variables next. Let's look at it again, just to get it down. That squared belongs to the b and the 6. The thing I want to reference here is that the 6 becomes squared and the b becomes squared because the exponents for both of these things are 1. And if I multiply 2 into both these, it's 2 times 1 and 2 times 1. Where 6 squared is going to give me 36. And of course, b squared, I'm going to leave as b squared. All right, so the thing you want to take away for today as we kind of segue into tomorrow, if I have a power of a power, meaning that I have a base and a power raised to another power, I can just multiply the exponents.